Hello friends, in the last video I discussed quicksort code. So here is the quicksort code which we discussed last time. So this quicksort partitions the array into left part and right part around pivot, and we sort left part recursively and we sort right part recursively. So let's try to execute this on a sample array. So if this is my array containing, let's say, 4 elements, 10, 5, 20 and 7. So my call, if the name of this array is A, for this array A, my call to the quicksort will be like this. Quicksort A, comma, this array is starting at 0 and it is ending at 3. So as soon as we have this call, quicksort starts executing. So we check, so here for this call L is 0 and R is 3. So we check whether L is less than R, so L is less than R. We go inside if and call this partition procedure for the same array, right? This partition procedure will execute on this array and it will execute like this. Here we'll assume this 10 as pivot. This will be our I, this will be our J. Right? So increment I till we find the element greater than pivot. So 5 is less than pivot. So 20 is greater than pivot. So our I will stop there. Decrement J till we find the element greater than pivot. Sorry, less than pivot. So 7 itself is less than pivot. Our J will stop there itself. So I and J have not crossed each other. So we'll swap I and J. So I'll bring 7 here and I'll bring 20 here. And continuing with this, I will move my I to this place and 20 is greater than pivot, so our I will stop here. Here is our I stopped. And we will decrement J till we find the element less than pivot. So 7 is less than pivot, so J will stop here. Now this time if you see I and J have crossed each other, so we'll swap pivot with J. Pivot is our 10, we'll swap this with 10. So I'll bring 7 here and get 10 here. So call to this partition procedure will yield this array 7, 5, 10 and 20. So I'll rewrite that array here 7, 5, 10 and 20. So we got the partition of the array such that left part contains 2 elements, 7 and 5, right part contains only 1 element. Right? So after getting this partition procedure will return the position of J is 2, that will be stored in J. Now let's continue with the next statement. Next statement is a call to quicksort for the same array is same, but this time, so second call, quicksort array A. It is starting at L, that is 0, but it is now ending at pivot position -1. Pivot is J and that is 2, -1, 1. Okay. So for this call we will start executing quicksort again, and this time L is 0 and R is 1. So if we check whether L is less than R, yes, L is less than R, so we continue in if block. So in if block we call partition again, and this time on the left part of the array with L as 0 and R as 1. So in partition procedure again we'll partition this. We have called partition here for this part only. Right? So that is this part. In partition procedure we assume this as pivot and this as I and same as J. So we check with I, we continue with I finding the element greater than pivot, 5 is less than pivot. We can't increment our I because this is the last element of this array. Decrement j till we find the element less than pivot. 5 itself is less than pivot. So we got the respective element, and now if you observe I and j have crossed each other, that means I is not less than j. So I will swap pivot with j. That means I'll do this swapping. I'll bring 5 here and bring 7 here. So giving me this array 5 and 7, and here is where our pivot is sitting. So that is happening, or this is the partitioning point. This is position 0, this is position 1. So after this partitioning, this partition procedure will return us the position of pivot, that is 1, and we'll store that in j variable of the second call, right? So the partitioning point is j is 1 here. So now we have the partitioning of this array. In fact, this was our array for which we called quicksort. So we got the partitioning such that partitioning point is on 1. So we call quicksort on the left hand side now. That is, left hand side is containing only one element, that is this element 5, which is on 0th place. Right? So we call quicksort on this. Right? So quicksort call on this I'll write here because of lack of space. I'll write it here. So quicksort on array is same, which is starting at 0. It is starting at 0 and it is ending at 0. It's starting at 0 and ending at 0. So that is my quicksort call, which is third call basically. So because of this call, we execute the quicksort function again. Here L is 0 now and R is 0. Right? If we check L less than R, it is not true. That means the if condition is false. Right? So we don't do any work here, in fact. So we'll return from this quicksort call without doing anything, and we'll return back to this statement which we have just now completed. We go to the next statement in this call. Right? So that means we have sorted this part on which we called quicksort. Right? Now there is nothing in the right part. That means, in fact, this quicksort call will do nothing, right? So this quicksort call gets completed with this part of the array getting sorted as 5, 7, which you can see here. 5, 7. I'll write the sorted array here. 5, 7. That we got because of this quicksort call. So now, of the first quicksort call, that is quicksort a, 0, 3, this statement is now completed. Right? Now we go to the next statement of this call, that is quicksort on a, j plus 1, that is right part of the array, and right part of the first quicksort call is starting at 2 and ending at 2. So that means the quicksort call on right part a, 2, 2. Right? So L is 2 and R is 2. If we execute the quicksort function for this call, we find L is not less than R because L is 2 and R is also 2. So we will not do any work in this call also, and we will return to our original call, that is parent call, that is this one. Right? So now we are back in this call on this statement which just now completed, which did no work because in fact what we did is we passed only one element, and that element was sorted. Only one element is always sorted, so we did not sort that. So now I am back in this call on the last statement which I just now completed, and I finished the quicksort call. Thus quicksort call for this array a starting at 0 ending at 3 gave us 5, 7, pivot is sitting here, and 20. The quicksort call gave us array sorted. So we'll discuss partition procedure in the next video. Thank you for watching.